So in this section we're going to look at integrals with U-substitution. It's kind of like backwards chain rule, but more systematic. So, this is just going to give us a way to deal with a bunch of different backwards chain rule problems. I'm doing air quotes with my fingers. You can't see this, so I'm moving on. So yeah, let's take a look at the first example. So we have the integral of the quantity 3x squared minus 5 raised to the fourth times 6x dx. So I'm trying to evaluate this integral, and I kind of have like a product rule, but also a chain rule in here because there's like a bunch of different functions. But this is what you do. This is how you can tackle this problem. We're going to do a change of variables to make this integrand more simple, and then we'll integrate it, and then we'll switch back our variables. So the first thing to do is choose a u value. So I'm going to make a substitution, and usually, not always, but usually you make the u value just the inside part. So it's kind of useful to think ahead, and I'll show you why. But here, if I look at this, the derivative of 3x squared is 6x, and look what I have on the outside, 6x. So something will happen with that, and this is how you do it. You choose your u value. So u, for me, I'm choosing u to be the inside function, which was 3x squared minus 5. And then I'm going to take the derivative. There's a shortcut for this, not really a shortcut, but shorthand for this, but I'll do that in a minute. So du dx, I'm taking the derivative, that's just 6x. I'll multiply both sides by dx. This is actually called the differential. So it's not a derivative anymore, it's a differential. We'll be using this later on as well. But we have du equaling 6x dx. So, and then I'm going to solve for dx because I want dx. I want to get rid of dx. I'm going to change this to u, so I need everything in terms of u. And it turns out that this will cancel out. So let's watch what happens. So I'm going to solve for dx by dividing both sides by 6x. And then I get dx equals just 1 over 6x du. Now I said I want everything in terms of u. Normally I'm not going to do all of this work. I'll show you the next example, but normally I'm not going to solve for dx every time. I'm just going to write it because I can do that in my head and it becomes a lot quicker. But now I'm going to make my substitutions. So I have u, which is 3x squared minus 5, so that's u, and then raised to the fourth power. That's not part of my u. Remember, otherwise it would look like that. So I didn't make the outside function part of my u. So this will be u to the fourth. And then I have times the 6x from here. And then instead of dx, I have this. So instead of writing dx, I'll write 1 over 6x times du. So 1 over 6x times du. And then look at that. Those cancel nicely. So I have u to the fourth du. Everything's in terms of u, so I can take my integral. This is getting the antiderivative. Then u to the fifth over 5 plus c. And then I'll switch back. U was 3x squared raised to the, or minus 5. So 3x squared minus 5. I'm going to raise that to the fifth and divide by 5. And then have the plus c there. So there we go. If we took the derivative of this, we'd definitely get back to that. Whoops, sorry, that with the 6x out there. So that's the first kind of problem that we'll have, where everything cancels out nicely. This would be my answer. That's just reverse chain rule, but with more systematic. U-substitution. I'm just switching variables. You choose the u. So let's look at example 2. Maybe you can try it just based on this. I highly recommend you pause the video and try it on your own. Yeah. So here's what you're going to try and do. Evaluate that. Remember, you choose your u. Let's take a look at this real quick. I chose my u to be this inside function. And when I took the derivative of the inside function here, I got this function, and they were able to cancel out. So what do you think U is going to be in this case, and then what will it cancel out with? It doesn't happen every time like that, but for these easier problems it does. So hopefully you paused it and did this. If not, do it now, or ask questions or whatever. But here we go. The U value here is going to be 3x to the 4th plus 5. And this is the shorthand version. So I'm not going to write all of those steps. I'm going to do the shorthand version. So I'll take du, the differential, and then that will be, what, 12x cubed. The 5 goes away, derivative of a constant is 0. And I'm already going to multiply by dx. So in the very, very first step, I'm going to get this line. Well, I guess it's the second step. So I took du dx, but then I multiplied by both sides. Multiply it to both sides, so I get this. And then I'm just going to solve the rest of it in my head. Dx, normally I divide by 12x cubed, but I can do that in my head. So I get 1 over 12x cubed times du. So there's that. Usually I just write down 3 lines for my U substitution. I do that, and then I switch my variables in my integral. So here I have u to the 5th, because that's what u is. So u to the 5th times the 12x cubed, and then instead of dx, I solved for dx, so I have 1 over 12x cubed. That's beautiful. Du, that will cancel, and now I only have u's. U to the 5th, du, so that's u to the 6th over 6th plus c, and that is equal to, when I substitute back in, 3x to the 4th plus 5 raised to the 6th divided by the 6th. Remember, that's just u, and this is just u, plus c. There we go. Hopefully these two problems are straightforward. This will get you through 1 through 4 at least, maybe even more. But there you go. Next video is going to be a tiny bit more complicated. We're using the same process. The reason why we do this process is because when it does get complicated, this helps us out, helps us keep things organized.